Welcome to the channel. So in this session we will be looking for structure elucidation by spectroscopy part 2 and myself Vikrant Dhamak. So in this session we will be looking elucidation by UV as well as IR and NMR, and also here the molecular formula it is not been given, only the molecular weight it is being given in the problem. So before starting the session, you should know some IR frequencies which are needed during the solving of these problems. So importantly over here we will just highlight, so you can do it from the book also. So I will superficially look among some frequencies. That is for carbonyl, so it is 1780 to 1650 and its intensity is quite strong. And see this carbonyl, it is again been bifurcated. So in some books it has been given like carboxylic acid. So whenever it is an carboxylic acid, so this OH it will also give an stretch in the region of 3300 and the intensity it will be strong. When it is an amide, so in the same region it will give the signal, but the intensity is the medium. Right? Only the difference between amide and carboxylic acid is that carboxylic acid it is showing a strong, and this one it will be in medium. Whenever it is aldehyde, so in 1700 it gives small peaks, two small peaks, and in case of an ester, so it gives in the region of 1250 to 1050 and it is strong. And there are some frequencies you should know, that is for nitrile and carbon-carbon double bond as well as for aromatic ring. So these are the only which we require in this session. We will start with the problem number 1. So the molecular weight it is 58. After that UV, no lambda max above 210 nanometer. IR 2941 to 2857 centimeter inverse and 1458 centimeter inverse. After that NMR value, that is 4.75 delta value, a signal it is triplet, J value 7.1 CPS, 29.4 squares, and second signal that is 2.75 delta value quintet and J value that is 7.1 CPS and 14.6 squares. So looking towards a problem, see there is UV it is not above 210 nanometer, it means that it is not active in the UV region. And looking towards an IR, so it is giving only an alkane type of an stretch and bend, so it is not having any type of an functional group. After that, the looking towards an J values, so J values they are similar, so it means that whenever the J values are similar, so it means that both the carbon they are adjacent to each other, and 29.4 square and 14.6 squares. So what is the meaning of these things squares? So squares it means how much area it has been occupied by that hydrogens, so it has been shown over here. In the earlier days it was been recorded on a graph paper, so that time the squares they were been calculated, so what is the area under scale, so that has been calculated. But nowadays there are softwares that you can directly calculate the number of hydrogens. Now we will see firstly what are the number of hydrogens looking towards squares. If we take a ratio, see the ratio it is almost 2:1. So the ratio that it should be an approximate. So that approximate ratio it is 2:1. After that we can increase number of hydrogens more. Why I have increased the number of hydrogens more? Because see here the signal it is triplet and here it is in quintet. So it means that adjacent is having 4 and here adjacent is having 2. So here it is 2 and here it is now 4. So that is why I have increased number of hydrogens. We can increase the number of hydrogens as per the ratio, but we will stop over here and we will proceed for further interpretation, because as per the requirement we can increase the ratio of that hydrogen also, but looking towards a signal I have written just 4:2. So after that, now n+1 formula. The first signal, that is triplet, so it means that adjacent is having 2 and it will give a triplet. So I will write a carbon. So the carbon skeleton I have written over here 3 carbons, because see, number of hydrogens on one carbon type of an hydrogens they are 4, and second type of an hydrogens they are 2. So one carbon cannot bear 4 carbons, and it can maximum bear 3 hydrogens, but here number of hydrogens they are 4, so I have written the 3 carbons. After that, looking towards and signal this triplet, so I will write on the adjacent carbon atom 2 hydrogens, right? So I have written 2 hydrogens. So now this carbon it will give a triplet. See, this first carbon it will give a triplet because the adjacent is having a 2, right? After that, going towards the next signal, so next signal 4 plus 1 it will give 5, so it means that quintet. So for quintet, the adjacent should have 4 hydrogens. So adjacent should have 4 hydrogens means, so they should be equally distributed on both sides. So I have started with the second carbon, firstly putting an hydrogen on second carbon, and now I will put the 4 hydrogens on the adjacent carbon atom. So let's put it. Okay, now it is clear that this carbon it will give a triplet, again this carbon it will give a triplet, and this carbon it will give a quintet. The triplet, this triplet, whatever the triplet it has been given by 4 hydrogens. So here you can see these are number of hydrogens 4, and quintet and number of hydrogens they are 2. So quintet. Now signal fits. Now only the problem is that now we'll calculate the molecular weight. So as per the NMR data, now structure is okay, but still structure is not fulfilled. So I have written 14, 14, 14. So 14, 14 means carbon 12 plus hydrogen 2, so it becomes 14. So 14 into 3 it becomes 42. So 42 minus 58, so still 16 it is remaining. The molecular weight it is given 58, so still 16 is remaining. So as per this data, the structure is almost complete, but as per the molecular weight we need more 16, and there is only now carbon it is having only one bond on the both the ends, that we should fulfill it, right? So we need to apply a logic that what is the of which kind of an atom it gives an 16 molecular weight. So according to that it will fit, right? So oxygen is one of an atom, so it fits with an 16. So number of bonds, carbon having each bond, so it is also been satisfied. Now structure is correct. So for oxygen, here there is nothing been given in case of an IR. So whatever the problems they are been given in the book from John Dyer, the values below this alkane bend they are not been given. If it would have been 1200, so we will come to know that these are the there might be an CO type of an bend, but on looking towards an NMR value, so it is showing 4.75. So it is quite shielded one. So shielded, it means that 4.75. If we remember the first part, so you will come to know that 4.75 it is for an oxygen or it is for an nitrogen. So nitrogen cannot fix over here because nitrogen's valency can fit but the molecular weight it will not fix, because nitrogen 14 plus 1, so it will become 15, but 15 does not come over here because we require an 16. So from NMR value also we come to understand that it is having an oxygen in between. Problem number 2, molecular weight 69, no UV about 200 nanometer. After that IR value, that is 2941 centimeter inverse, 2273 centimeter inverse, and 14 centimeter inverse. NMR value is 2.75 delta, and the signal it is septate. J values both are similar, that is 6.7 CPS for first signal and second signal also, and 4.2 squares for first signal. After that second signal, that is 1.03 delta value, and doublet J value it is similar as the first one, and after that 25.8 squares. So let firstly calculate the squares, 4.2 squares and 25.8. So I have taken a ratio over here, that is 1:6. So 1:6, it means that number of hydrogens, the number of hydrogens we have calculated, and simply looking towards the data we will come to understand that septate, it means that adjacent is having 6 hydrogens, and doublet, it means that adjacent is having only one type of it is having only one hydrogen. So now this data is sufficient. After that, coming towards an n+1 signal. So n+1 signal, so firstly we will record for unseptate. So septate, it means that 6 plus 1. So adjacent it is having 6. So adjacent, whenever the adjacent it is having 6. So we have seen such kind of problems in part 1 also. So adjacent is having 6, it means it should be in branch, because hydrogen number of hydrogen on one carbon, they are not more than 3. So we will consider that there are 2 branchings. So I will write a structure over here. So branch I have written because the number of hydrogens, they are 6 on the adjacent. So adjacent to this middle carbon. So I will put a hydrogens, number of hydrogens. After that, next signal, that is doublet. So doublet, it means that adjacent is having only 1. So I will put up 1 hydrogen on the adjacent carbon atom. So now both the signals as per NMR, they are now clear, that one is giving septate and second one is giving in doublet. So adjacent is having 3 plus 3, 6, and doublet, it means that adjacent is having only 1 hydrogen. Now what is remaining further? So we can see more data further. Now if we calculate the molecular weight, so 15 plus 13, 15 for CH3, 15 for CH3, and for CH, that is 13, so it becomes 43. So now remaining molecular weight from 69 minus 43, it is 26. Now if we look towards an IR data, so IR data, it is showing that it should have an cyanide. So we'll put a cyanide and see the molecular weight of cyanide, whether it is matching or not. So 12 plus 14 plus 43, it becomes 69. So now the structure is correct. So this will be the final structure, and as you can see, this carbon which is giving an septate, so it has been de-shielded type of an carbon, that is, it is having a delta value more. Molecular weight 71, UV not above 200 nanometer. After that IR, so IR, it is similar as the previous problem, 2941 centimeter inverse, 2273 centimeter inverse, and 1460 centimeter inverse. NMR value, that is 4.22 delta value singlet, and it is giving 16.8 squares, and delta value, that is 3.39 delta value, singlet 23.9 squares. So let's firstly calculate the number of squares with a number of hydrogens. So I have written here ratio 2:3. So we cannot divide by 16 to 23. So I have written 2/3. So number of hydrogens here, it might be 2 hydrogens and 3 hydrogens. So let us see. After that signal, they are singlet. So singlet, it means that adjacent is not having anything. So I will just write first carbon, and this carbon, it is giving an singlet. So adjacent is not having anything, but itself it is having some hydrogens. So number of hydrogens I have written here 2, because first signal it is showing 2 hydrogens. And for second signal, so I will write number of hydrogens 3, because second signal it is having 3 hydrogens as per the squares. And now if we look for an further interpretation, see now molecular weight we will calculate, that is 14 plus 15, it will give 29. So 14 for this first carbon and second carbon 15, and it becomes 29. And from the IR data, it has been understood that it is having a cyanide. So I will write a cyanide. Molecular weight 12 for carbon and for hydrogen 14. So it becomes 55. So I will put a cyanide somewhere. And after that, so the remaining molecular weight, it is 16. So from NMR value, we understand that it is 4.22. So it means that it is having oxygen in between, because molecular weight now it is remaining only 16, and so that is why we will put an oxygen and see the structure. So now looking towards towards an NMR values, the first signal it was 4.22, because it is having cyanide as well as an oxygen. And second signal, it is 3.39 delta value, it is just having an oxygen in between. So that is why the delta value for this carbon it is less, and for this carbon it is more. And this is the final structure of the problem. Problem number 4. Molecular weight 72. Now here it is an UV active compound. The lambda max it is 274 nanometer. So from this UV we come to understand only whether it is having conjugation or not. IR it is 2941 centimeter inverse and 1715 centimeter inverse and 1460 centimeter inverse. So the first value and third value, so they are justly alkane stretch and bend. So in between it is having 1715, so it will be an carbonyl. After that NMR value, that is 2.48 delta value quartet, and J value that is 7.3 CPS and 12 squares. Second signal, that is 2.22 delta value singlet 17.6 squares. After that 1.07 delta values triplet, J value 7.3 CPS 18.2 squares. So let's firstly calculate the squares, and from that squares we will come towards an ratio, and from ratio we will come towards an hydrogen. So I have divided by 6, so that is why we get the ratio. And this quartet and triplet, they are having the J value similar. So it means that both the signals, both the carbons, they are adjacent to each other. So now we'll calculate by n+1 rule. So adjacent to each other, so that is why I have written 2 carbon adjacent to each other, so that we can solve the quartet and triplet easily. So whenever you come across such kind of quartet and triplet having the same J values, so it means that they are adjacent to each other. So 3 plus 1 gives quartet. So I will write 3 hydrogens on the first carbon, and I cannot write carbon number 3 hydrogens on this carbon because we have to join further. So I have written on the first carbon, and now triplet. So triplet, it will be given by 2 plus 1. So adjacent is having number of hydrogens 2. So the signal will be triplet. Okay, now first carbon it will give a triplet. This carbon it will give a triplet. And it is giving a triplet and number of hydrogens are 3 on it. Right? So from this it has been understood number of squares. Right? From that we have calculated number of hydrogens. So from this it has been understood, and quartet itself it is having 2, but adjacent it is having 3. So from this quartet signal also we come to understand. After that, the signal for this second one, that is 2.22 delta value. So the signal that is singlet, it means that adjacent is not having anything. So I will write a carbon having no adjacent type of an adjacent is not having anything. After that we will calculate now molecular weight. So I have written 3 hydrogens over here because 3 is the, as per the square, it is having 3 hydrogens. So 15 for first carbon, after that 14 for second, and after that 15. So it becomes 44. So total molecular weight till yet it is 44, and remaining it is now 28. Now looking towards this higher values, so it is showing that it is having some carbonyl type of a functional group. So what kind of a carbonyl, it depends now on molecular weight. So how much it has been remaining. So 28 it has been remaining. If we calculate for carbon and oxygen, so carbon and oxygen it is 28, and now the value it is exact as molecular weight, and I have put the carbonyl in between. And see, carbonyl, the adjacent to the carbonyl, so it is not an aldehyde, it is not an carboxylic acid. It is because the molecular weight it does not fix. First criteria is that, and secondly, if we look towards this NMR values, so it is coming in the ketonic region. Whenever the values they are almost near to 10, it is carboxylic acid, and almost to 9, it is an aldehyde. So that cannot be, and no further addition can be done for like amide or ester. So that cannot be because the molecular weight it does not fix. It does not matches. So we are not adding. So this will be the final structure. So molecular weight is now exact, and the NMR data values they are also exact, and IR data it is also an exact. After that, problem number 5, molecular weight it is 73, lambda max it is 219 nanometer, it means that it is UV active. Number of ranges, IR 3413 centimeter inverse, so it means that it might be having OH or NH type of an group, and also it is medium. After that 3236 centimeter is inverse, and it is medium. After that 3030 to 2899 centimeter inverse, it is also medium. And 1667 centimeters inverse, it is strong. So it is showing that it might be having carbon-carbon double bond. After that 1634 centimeter inverse, so it is also strong, and 1460 centimeter inverse, and it is medium. Now coming towards an NMR value, that is 6.5 delta value, and it is showing a broad singlet of 13.0 squares. After that 2.25 quartet, 7.5 CPS and 12.8 squares, and 1.10 delta value, triplet J value, that is 7.5 CPS and 19.7 squares. So J value, it means that this quartet and triplet, they are adjacent to each other. Now we'll calculate the number of hydrogens according to the squares. So I have divided by 6. So approximate, it is showing the ratio 2, 2 and 3. So it cannot be in point. So just you have to write numericals. So number of hydrogens, they are 2, 2 and 3. So quartet, triplet, they are adjacent to each other. Now we'll calculate the signal. Quartet, it means adjacent is having number of hydrogens 3. So I will write 3 for adjacent. And for triplet, number of adjacent, it is 2. So the first carbon, it will give a triplet, and second carbon, it will give a quartet. Now it is showing a broad singlet, and how this broad singlet comes. So let's firstly calculate the molecular weight, that is for 15 for first carbon, and second it is having 14. So it becomes 29 totally, and so remaining it is 44. See, from the signal, it is almost been understood that 1667, it means that it is for carbon-carbon double bond also, but it is strong. So it means that it is for an carbonyl. And carbonyl, so what kind of an carbonyl it is? So it is an amine type amine, because the signal over here, it is an medium. Right? The intensity of signal, it is medium. So the difference only in the OH and NH, it is that intensity of this signal, it is medium for an amine. So here I have written that is why amide type of an functional group. And as also there is one more logic that how it can be. See here, number of an hydrogens for first carbon, it is showing in broad singlet, but number of hydrogens that are 2. So 2 it means that the functional group, it should have an 2 hydrogens. So here cannot be an OH, because the signal here is also an medium type, and this 6.5 delta value, so it can be for OH also, but here number of hydrogens are 2. So it means that it should be an amide only. So I will write amide, and now we will calculate the molecular weight of a compound. So 29 as we have calculated for triplet and quartet, and after that 44 for carbon 12, oxygen 16, and nitrogen 14, and hydrogen 2. So collectively it becomes 44. Now the total value, that is 73. So it matches the exact molecular weight. And from this carbonyl or amide, we can say. So from this amide, it has been also understood that UV, it is an UV active type of a compound. That is why it is showing an lambda max 219. Problem number 6. Molecular weight, it is 88. Lambda max, it is 206 nanometer. IR 3049 and 2934 centimeter inverse. 1736 centimeters inverse, and the signal is strong. And after that 1445 centimeter inverse, so signal is medium. So it means that it is having an carbonyl in between now. The delta values, 8.07 delta value singlet, 5.9 squares, and after that delta value 4.22 triplet. So J values, they are similar for all the signals. So it means that all the signals are adjacent to each other. So first it is second signal, it is having 12.2 squares. After that 1.67 delta value, and sextet, it is having squares 11.6 squares, and after that 0.95 delta value triplet. So it is having J value similar as earlier. and number of square, that is 18.6 squares. So let's firstly calculate the number of hydrogens from the squares. So I have divided again by 6. So 1:2:3, it will be the ratio. So let's firstly calculate the signals. I have written 3 carbons in the line because the J value, it suggests or it indicates that they are adjacent to each other. So I have written 3 carbons in the row. So triplet, so adjacent is having 2. After that sextet, so sextet, it means that adjacent should have an 5. So I have put 5 hydrogens on the adjacent to this carbon. So these are the 5 hydrogens, here 2 and here 3. And after that triplet, again it is showing a triplet. So triplet, so the triplet I will. So triplet, it means that adjacent is having only 2 hydrogens. So it can be a triplet. See, this triplet and this first one triplet, they are different. See, this triplet, it is having a delta value 4.22, and this last triplet, it is having 0.95. So don't confuse with that triplet. See, this triplet, it means that it is quite having a delta value low, and it is not having any type of an electronegative atom in the adjacent. But this 4.22, it indicates that it might be having an oxygen. So let us see whether it is oxygen or whether it is a nitrogen. So from IR, it is not showing that it is a nitrogen, but strongly it might be an oxygen. So let's firstly calculate the molecular weight. 15, 14, 14. So 15 for first carbon, 14, again 14 for second and third. So it becomes 43. Total molecular weight, it is 88. Now from this IR value, let's firstly put an functional group. So I have written a functional group over here. Now let's okay, I have written aldehyde over here. So let's see whether it is aldehyde or any other. From molecular weight, we can understand it, what kind of an functional group it is. Because see, I have written aldehyde here. One more reason is that, see, NMR value, it is 8.07. So aldehyde, it is giving in the region of an 8.07, and after that it is only an carboxylic acid. So I have written aldehyde because NMR value, it shows that it will be an aldehyde. So let us now calculate for 12, 16 plus 1 plus 43, it becomes 72. Still something it is remaining. So remaining, that is 16. Now after adding a 16, we get 88. So here it might be an oxygen. Why? Because see, the NMR value, it is 4.22 delta, and that is why I am putting oxygen over here in between. And now the structure, you can see, correlate the data with NMR, IR and molecular weight. So structure, it is fulfilling all the criteria, and also it is UV active because it is having this type of an functional group. Coming towards on problem number 7. Molecular weight, it is 89, and UV, it is 204 nanometer and 276 nanometer. After that IR, 13, 30, 29, 24 centimeter inverse. After that 15, 55 centimeter inverse, and 14, 66 centimeter inverse, it is medium. Here the NMR value, that is 4.70, So it means that it is having nitrogen or oxygen at the adjacent, and it is showing in separate. The J value, it is similar for both the signal, that is 6.7 CPS, and squares 6.2 squares, and 1.53 delta value after that doublet. So the coupling constant, it is similar, that is 6.7 CPS, and square, that is 37.8. So such kind of problems also we have seen earlier. Whenever it is septate and doublet, so it should be a branched one, because one carbon can bear only 3 hydrogens. So here number of hydrogens I have written 6, so I have again divided it by 6. So number of hydrogens we get 6, so the ratio it will be 1:6. The signal, that is n plus 1. After that, septate, it means that adjacent is having total number of hydrogens, that is 6. So I have written 6 number of hydrogens, and 2, it means that doublet, so the adjacent should have only 1 hydrogen, so I have written H over here. And after that, so now this signal fits with this delta value, with this NMR values. So from NMR value, here you can see that here it is not showing any kind of an oxygen from an IR value, but from NMR it might be having nitrogen or it might be having an oxygen, but IR it does not support for an oxygen. So now let's calculate firstly a molecular weight. So 15 for this branch CS3 and 13 for the middle carbon, so it becomes 43. So still remaining it is 46. See the year of one value, actually this problems from where I have taken. So after that 1466, or after the alkane bend, the values are not been given in these problems. So here it might be and nitrogen. If it is nitrogen, then we have to adjust some more atoms to it. So it can be a nitro, as per looking towards an 1555 centimeter inverse. So I have written a nitro. Now let's calculate the molecular weight. So nitrogen 14 plus 32, it becomes 46, and earlier 43, it becomes 89. So now molecular weight it also fixed, and from the only one of an value of a nitrogen, actually the nitro group it gives and 2 signals, but after the bend the values are not been given in such kind of problems. And also from delta value it has been understood either it has been having a nitrogen or oxygen at the end. So now structure, so this is the final structure for this given problem. After that, problem number 8, molecular weight it is 104, UV it is 255 nanometers, IR 3125 to 2857 centimeter inverse, 2695 and 2625. So these are the 2 weak signals, and 1718 centimeter inverse it is strong. After that 1466 centimeter inverse it is medium. So from this it has been understood that 1718 it means that the signal they are for an carbonyl, and what kind of an carbonyl. So this can be understood from this 2 weak. See, you cannot find all these kind of values in all the books, but you can find in the Pavia book that it is given for an aldehyde. So whenever there are 2 signals in the region of 2700, so it means that it is having an aldehyde type of an functional group. So let's see from an NMR data also. So 10.95 singlet, 5.4 squares. After that 4.13 delta value, singlet 11.0 squares, and 3.66 delta value, quartet J value 7.1 CPS, 10.6 squares. After that 2.27 delta value, triplet J value 7.1 CPS, 16.2 squares. So let firstly calculate the number of hydrogens. So number of hydrogens, so I have again divided by almost 5. So the number of hydrogen, that is 1:2, 2:2, 2:3. So now let's calculate the signal. So 3 plus 1, it gives quartet. So quartet and triplet, as earlier we have seen, so the values are J values are similar. It means that they are adjacent to each other. So let's firstly put the quartet and triplet. So this second carbon, it will give quartet, and first carbon, it will give a triplet. Now after that, it is showing a singlet. So I will individually write a singlet separately, and this singlet, it is having 2 hydrogens. So I have written 2 hydrogen, but adjacent carbon is not having anything. Whether it is carbon or not, we will see, because here it is showing 4.13 signal. So it means that carbon, it should have an oxygen or nitrogen in between, but from molecular weight we will come to understand, because it is probably an oxygen. So the delta value for this quartet, it is also 3.66. So I will put oxygen in the middle. So before that, let's firstly calculate the molecular weight. So 15, 15, 14, 15, 14 and 14, it becomes 43. After that, it is having some type of an carbonyl. So that carbonyl, probably it is an aldehyde, because from the IR value, it is showing that in the region of 2700, it is showing a weak signal, small to weak signal. It means that it is an aldehyde. So singlet for that NMR value, that is 10.95. So it is quite deshielded. So it is quite deshielded. It means that it is having it might be having an electronegative atom in the adjacent. So let's see by a molecular weight. So 43 for these first 3 carbons. After that, 12 plus 16 plus 1, so it becomes 72. So now 72 minus 104, it becomes 32. Now I put oxygen over here, because 32, so 32 divided by 2, it becomes 16. So from this delta value, it is indicating that it should have an oxygen in between or nitrogen in between, but there is no data given in the IR that it is showing a nitrogen in the between. It might be an oxygen as per the calculations of a molecular weight. So I have written oxygen in between, because the remaining now it is only 16. So I will write one more oxygen, and now it fits the structure. See the delta value for this type of an aldehyde, it is around 8 or 8.5 or lastly a 9, but it is quite deshielded. It means that it is having more electronegative atom. So that is why it is coming 10.95. So here I have written oxygen. Now the structure fits. So now the molecular weight, it becomes 104. After that, problem number 9, molecular weight 108, UV 255 nanometers, IR 3401 centimeters inverse strong. After that, 3077 centimeter inverse medium, 2899 centimeter inverse medium, and 1499 centimeter inverse weak. And after that, 1456 centimeter inverse, and it is medium. See this, it is indicating that 3401, it means that it is having an OH, and this OH, now here there is no carbonyl or nothing, but only from NMR values. Now we will come to understand some things. That is 7.26 delta value singlet, 24.7 squares. After that, 4.60 delta value singlet, 9.8 squares. After that, delta value 4.86 delta, it is showing in singlet and giving a 5.2 squares. So now let us calculate the ratio, and from this ratio we can calculate number of hydrogens. So number of hydrogens, they are 5. So I have divided by 5. So almost it is showing 5:2:1. And see, from the NMR value, it is showing that it is having an aromatic ring, and this aromatic ring, it is showing 5 hydrogen. It means that it is being substituted at one position. So remaining 5 hydrogens, they are on the ring. And also we will calculate the molecular weight. See, 12 carbons and 1 hydrogen into 6 into 5, it becomes 77. And it has been, as it has been substituted, so it means that it is having one hydrogen it has been substituted, because number of hydrogens here are 5. After that, and it will show a singlet as it is given in the data, that it is showing in singlet. See, the next signal, that is 4.60. So 4.60, it means it is having an benzylic proton. So the benzylic proton, it comes in that region, and according to the square, it is having 2 hydrogens. So I have written here 2 hydrogens, and adjacent, in the adjacent, it is not having any type of an hydrogen. So it is showing in singlet. So the now molecular weight, it is 77 plus 14 for this CH2, 14, and it becomes a 91. So 91, and from this now 91, so remaining molecular weight, it is 17. So 17, why I have written over here OH, because the value for NMR, it is 4.86, and it is showing in squares 5.2. So this value, it can be for an amine also, but amines cannot be, because 3400, so it is showing a signal strong, and strong signal, it is always for an OH. And also this 3077, it is indicating that it is showing an aromatic type of an stretch, and 2899, it is for this CH2 type of an stretch. So now the molecular weight, it becomes 108. So molecular weight is also exact. And the last signal, that is singlet. See, because carbon, though this carbon is having an adjacent OH, but whenever it is only an carbon over here, then only a coupling can be. So there cannot be a coupling when there is another atom rather than carbon. After that, problem number 10, molecular weight, it is 112. So there is no lambda max about 200 nanometers. It means that it is not active. And from the ranges, we can understand that from the ranges, these are alkane ranges, stretch and bend. After that, NMR value, it is 1.52 delta and singlet. So this is the only problem it has been given. No further data it has been given. So there are lot much logic how to solve such kind of problems. See, there the signal, it is given only in singlet. So it means that all the carbon, they are having number of hydrogens similar, and all are having number of all are having same type of hydrogens. So and from UV, it has been understood that it is an alkane, simple alkane. And from IR also, it has been understood that it is not having any type of functional group. So in such kind of problem, we need to calculate firstly number of carbon and hydrogen. So let firstly divide it by CS3. So probably we will take this CS3 if it is like tertiary butyl, 2 tertiary butyls are joined or not. So we will look for it. Now what we will do, we will take a molecular weight and divide it by 15. So the value, it becomes 7.46. So it means that it does not fit with the structure. It does not fit with the structure means what? It should not, the value should not come in the decimal. So what we will do, now we will go for an CH2. Beyond going CH2, further we can also go for CH also, but whenever it comes to an CH, it should have a double bond. But from the IR, it is not showing it is having any kind of a double bond. So we will divide molecular weight by 14. The molecular weight of CH2 is 14 and it becomes 8. So now it becomes exact, right? So I will draw all the CH2. So I will draw 8 CH2 in the row. But the problem with this CH2 writing in the row is that number of carbons they are fit, number of hydrogens they are fit, number of signals they are fit. But only the problem is that the structure should be joining to each other, right? This CH2 and this CH2 they should join, and for that purpose now I will make that structure cyclic, so it becomes octane, right? 8 carbon, so it becomes octane, and this is alkane, and that is why it is not having an UV about 200, right? Because it is not having a double bond, or it is not having any type of a chromophore. And now molecular weight also it exactly fits, and the structure is octane. So thank you. For further, if you are having any kind of a problem, you can write it in the comment box, and I will prepare further more videos on some difficult problems other than this. So we have completed part 2.